Going over all of the math in AP Macroeconomics. Now, that may be somewhat misleading. We're not going over all the math in AP Macro, but we're going over the foundational stuff, the stuff that the AP exam are going to ask you directly to use math, not necessarily some easier stuff or some more niche stuff. This is the foundational stuff you need to know. And it's mostly simple math. It's mostly either arithmetic or basic algebra. So the math is pretty easy. You just need to know what to do in specific problems and to not get tricked. This video basically assumes you've covered all of AP Macro. We're just going over these concepts and understanding how we actually do the math. So remember, when we're calculating GDP, there's two main approaches we use. First is the expenditures approach. The expenditures approach is our classical formula, C plus I plus G plus X minus M. Consumer spending plus investment spending plus government spending plus net exports. And that always confuses people. X stands for net exports, so that means we're exporting stuff. M stands for imports. And we subtract imports from exports, and that determines our GDP. So always remember, more exports means a higher GDP, more imports means a less GDP. So let's do a practice problem. The following table provides data for a country's economy in billions of dollars. Using the expenditure approach, calculate a country's GDP. So this part's easy. We know C plus I plus G. So let's add those up. 5,000, I'll just abbreviate 5K, plus 1.2K, plus 1.8K. And in total, that's 8,000 or 8 trillion. So remember, it's in billions, so it's still 8 trillion. The part where a lot of people get confused on is this part, exports and imports. It's always X minus M, exports minus imports. So 900 minus 1,100, we get negative 200. So that means net exports, we're basically importing too much goods. That's hurting our economy. So now it's minus 200. And then our final answer is 7.8K or $7.8 trillion. What I've seen a lot on the AP exam is that they always add some random thing, whether it be rental income, profits, or interest rates, or here are transfer payments. Always remember, they're trying to trick you. The GDP formula is just C plus I plus G plus X minus M. There's no transfer payments whatsoever. Always remember the foundational stuff. Don't get tricked by the AP exam. Remember the income approach, you add up all the income earned, and that can calculate GDP as well. Labor income, rental income, interest income, and profits. Very similar to this table, but they'll give you all those different types of income. Just remember, if they give you something you've never heard of, or something that's not a part of income, like let's say they give you interest rates, or they give you bond prices, or something crazy or weird like that, remember, they're just trying to trick you. It's just these four that you need to know. Now let's talk about inflation. Inflation is just a general increase in prices. The CPI tries to measure this for average goods a normal person would buy. So think like eggs, milk, bread, normal things people would buy. You wouldn't include a military tank in CPI. You would include stuff that me and you can buy with our average incomes. And it's a simple change of a percent change problem. Price in market basket divided by price of base year times 100. So let's say in the market basket, so let's say 2020 or 20 for short. Let's say that it's let's say a carton of eggs costs $1. Then let's say in 2025 it costs $1.25. So how do we calculate that? The market basket is the current year. So the market basket is 2025. The base year is the year you're comparing it to. So in this case, it's 2020. The base year is always in the past. So $1.25 divided by 1 times 100. And you get the CPI of 125. Just remember it's a simple percent change problem, and don't get confused on the years. Now you need to know the distinction between real versus nominal. Whenever you hear nominal and real, nominal always stands for not adjusted to inflation. Real always stands for adjusted to inflation. Just remember that distinct difference. The GDP deflator measures the price of all goods produced. So it measures the price of milk and eggs, for instance, but it also measures the price of things we don't generally buy. Things like yachts or military tanks, basically everything in the economy. And the way to do that is nominal GDP over real GDP times 100. So let's do a problem for that. The following data represents nominal and real GDP in a hypothetical economy. Calculate the GDP deflator for year 2024. So how do we do that? Well, nominal over real. So let's do that. Nominal GDP for 2024, 13,200. Real GDP, 11,000. So 13,000 times 1,200. 13,000, 1,200 divided by 11,000. Times 100. What we get, let me get a calculator. 200 divided by 11,000 times 100, and we get 120. It's kind of like our CPI. But what a lot of times I've seen on the AP exam that they try to trick students is that they'll bring up 2 different years or 3 different years, and they'll ask you calculate a GDP deflator for 2024 or 2020, and then students use the wrong years. Like they'll use 13,200 divided by 10,000, or they'll look for the percent change over time. Remember, GDP deflator is simply nominal over real. It's not taking into account different years specifically. Now we need to know marginal propensity to consume and marginal propensity to save. Marginal propensity to consume and save are simply your basically how much you save and spend per dollar. So if, let's say we have $100, or let's say I just earned $100 through my job, and I spend $80, and I save $20. That means my marginal propensity to consume, or what they call MPC, that's equal to 0.8. 0.8, and then my marginal propensity to save is equal to 0.2. Because I consumed 80% of my income and I saved 20%. That's your marginal propensities. Another way to calculate it, change in consumption over change in disposable income. It's the same thing we just did, basically. Change in consumption. So that'd be 80 divided by change in income, 100, we get 0.8. Always remember marginal propensity to consume and marginal propensity to save, they always add up to 1. So in this case, 0.8 plus 0.2 is 1. That means if you say, we know the marginal propensity to consume is 0.5, for instance. Let's say it's 0.5. That means the marginal propensity to save is 0.5. You can calculate them easily. Then you have to also know the spending multiplier. The spending multiplier basically shows how much of if the government spends the X amount of dollars, how much of it is going to actually benefit the economy. The way we do it is 1 over MPS or 1 over 1 minus MPC. Then the tax multiplier for when the government increases or decreases taxes and they try to determine how much is this going to boost the economy, that's MPC over MPS. So let's do a bit of a longer question. Suppose a country experiences the following changes in national income and consumption. So we see the initial income is 5,000, new income 6,000, initial consumption is 4,500, new consumption is 5,300. Let's calculate the MPC and MPS first. So remember, it's change in consumption over change in income. So let's do that. 5,300 minus 4,500. So we get 800 over 6,000 minus 5,000. The change in income, I'm not going to write it down, but it's 1,000. So we get 800 divided by 1,000. 800. That X is out. 800 divided by 1,000. That means our marginal propensity to consume, the amount of money we spent is 0.8. So if our marginal propensity to consume is 0.8, remember 1 minus 0.8, that's marginal propensity to save. That means that's 0.2. So now that's the bulk of the work there done. Calculate the spending multiplier. Spending multiplier is just 1 over MPS or 1 over 1 minus MPC. I'm going to do MPS because that's just easier. 1 divided by 0.2. 1 divided by 0.2 is equal to 5. That's our spending multiplier. What that means is if the government, let's say, spends $10 billion on the economy, that means the general increase in the GDP or the general increase in the economy will be 50 billion. You multiply the spending multiplier by how much you spend. If the government increases spending by $200 billion, by how much will total output increase based on the multiplier? Again, it's just like I talked about. It's spending times the multiplier, so 200 billion times the 5, that's $1 trillion. Then I know it's not mentioned here, but let's try it. Let's do the tax multiplier. So MPC divided by MPS, 0.8 divided by 0.2, we get 4. What does that mean? That means if the government, let's say, decreases taxes by 100 billion, that our economy is going to grow by 400 billion. You multiply by the tax multiplier. So just remember these two multipliers, how to use them, and how to calculate MPC and MPS. Now we have the quantity theory of money. The quantity theory of money is basically a theory that states the relationship between the general price of goods and money circulation. So it's basically showing a general relationship between all of these quantities. Money supply times velocity, so the rate at which the money is being spent, kind of like what we talked about with the multipliers, is equal to price times quantity. And price times quantity, if you can't tell, we might see in our basic supply and demand graph, price times quantity is simply GDP. So that's actually just GDP. So always make note of that. So let's do one last question here. Using the data above, calculate the nominal GDP for the economy. So we have money supply, velocity of money, real GDP. So real GDP is simply the Y, the quantity almost. So how do we do that? Well, M times V, 500 billion times 4, we get 2 trillion. Real GDP, or Y, is 1.8 trillion. So we have 1.8 trillion, and we're trying to find the value of P. So P is our variable here. So it's kind of like a basic math problem. What do we do here then? How do we solve for P? Well, it's like math. You would divide by 1.8. So divide both sides by 1.8. To divide by 1.8, let me do a calculator real quick. About 1.1, let's say. So 1.1 is equal to P. So P is just 1.1. That's P. Or sorry, that's the nominal GDP. So the nominal GDP, the nominal GDP would be 2 trillion. Nominal GDP is this. Then the P here, sorry, we were calculating the wrong thing. The P here is 1.1. So M times V, that's the nominal GDP. That is nominal here. P is simply 1.1. We solved it using the algebra problem. If the central bank increases the money supply by 10%, while the velocity in real GDP remain the same, what is the expected inflation rate? So let's actually do all of that. So let's say that they increase the money supply by 10%, from 500 billion to 550 billion. So then it's 550 billion times the 4, that's 2.2 trillion. So it went up by 200 billion. Then in real GDP, 1.8 trillion. Then we have to calculate the inflation rate, or price, because price is technically inflation. So what would the new inflation rate be? Well, 2.2 divided by 1.8. We get an inflation rate of 22%, pretty high. The actual number I got is 1.22, but remember inflation is basically percents, so 22%, really high. So that's everything. That's all the main things, that you need to know about AP Macroeconomics. Mostly it's simple arithmetic, adding two numbers, percent change, or you could have more of an algebra problem, kind of like this, where you're missing a variable. Those are the main types of math problems you need to know. All you need to understand is how to apply them on different topics in AP Macro.